YouTube. Alright, so I'm gonna make a quicker video here. Basically, all I want to say is that I got exception handling working. We can go here, step into foo. Next, bar is going to throw. You can see this by looking at bar calls Baz, and then Baz throws a 5, an integer. Now here's the thing. All this other extra stuff here is just to prevent the compiler from optimizing all the code away, but really this will always happen and will throw a 5. So now, if I put a breakpoint at 69, nice. Check it out. Boom, here we are. Be thrown has the number 5, and if I print out catcher's mitt, it's 0. Press next. Print out catcher's mitt again. 5. Nice. So it works. Alright, so just kind of give you an idea of what's happening under the hood. I'm going to reset this. And what I'm going to do is put myself throw. So this is my implementation of CXA throw. You can see it. Actually, I'll just play it to it. Boom, here we are. So you've already thrown our object. We got our type info. We have our destructor here. And here's where we extract the exception object out of the thrown exception, save our info, save our destructor, capture our CPU state, unwind this function trivially, and then step into raise exception, or at least virtually unwind this function. And then from here, we have a sequence of things that we do. First thing that we do is we get the current frame. So I'm just going to go from here, function address, parentheses, Stizzy. And we can see that we are currently at, let me put a hex on that, 9C0. If you go to the code here, 9C0 is Baz. And what will happen here is go next, 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 next. I'm going to do layout split so I can go to next for individual instructions. Yeesh. Alright, come on. Yes, alright, so next. I just want to get to the unwind frame, step into that, and then here we can actually unwind it. So we go through the whole unwinding steps and stuff like that, runs all the commands and all that. Finish this. We get all the other entries. I can show you what this looks like. Function address here. This calculates the function address given the entry value. 9EC, 9EC. We're at bar. And this keeps happening until eventually, I'm going to put a breakpoint here. Now, if we do that one more time, you'll see that we are at A0C, A0C, and that's foo. Now, foo actually has a couple catch statements. You can kind of see that by the end cleanup, catch, begin, end catch, and such. Here's where we start getting into the more interesting bits of this. And then once we go to that next area, we're going to step into this function. And this does the calculation by unwinding the cleanup and catch information, and then determines if it can be caught, and then if it can be, it'll then jump over to the code base. I don't know how to actually unwind these functions that actually have catch statements. The way that the unwind information is placed is a little bit different. I gotta figure that out. This thing is a bit it's a bit fragile, so I'm still working on improving it and making it work for more use cases. But yeah, we at least have something that pretty much does most of the work. Here we are grabbing the type info from the particular section. We're seeing if it's the correct type info. It is the correct type info. Now we're setting up the CPU with the R0 represents the first parameter of the catch. And then R1 is actually like the index to the switch case statement that GCC generates. If you look over here, you can actually see this is where the landing pad will place us. And you can see it compares R1 to 3 and then branches to the appropriate place. Down here, it'll then check if it's 1, which will branch over here, and check if it's 2, and then branch over here. So it transforms your multiple catch statements into a switch case statement. And with that and some other things, GCC has been able to compress the exception data even further than what you would see for the ARM ABI, which is really neat. And yeah, so right here, I can start iterating through all the instructions. This is a very trivial way of going about this. It's probably not very fast, but you know, hey, it works. And then next, boom, here we are. Compare with 3, doesn't work. Compare with 1, boom, here we go. Now we're in the catch. Now we're inside. We load it up, move out of here, do the end catch, then go back to the start, run the destructor, and get out of here. And we're done. That's pretty much it. So exception handling is working. Now it's just time to improve it, work on it, and maybe even do some performance testing to see how fast it is compared to the built-in exception handling algorithms.